Okay, I hope. So let's start our session at the annual uh, conference led by our institute devoted to foresight and science, technology, innovation policy. And here our session devoted to, so we call it new geography of innovation. And I'm just want to reflect as a moderator, of course, about this new geography. What does it mean? I think that last decades we saw this new geography, and it means several times simultaneously, several points simultaneously. First, we saw new continents and new countries very growing, like China and India, and that means new geography, and new cities as well, like Shenzhen. Uh, Second sphere of this new geography is new formats. So, yes, do you hear me? Sorry.
Yes, yes, that's fine. Just a little lagging, but okay.
Yeah, yeah, yeah. I see that my picture doesn't move, so I'm afraid, but I'm going on. So, new formats. It's not on cities or regions, but also clusters, agglomerations, technology parks, and so on. And we must take it into account when we're talking about geography. Then, new actors. 20th century, when we're talking about innovations in cities, we're talking about scientific organizations, universities, we're talking about large corporations. Then, in the beginning of the 21st century, we start talking about startups. Now, uh, this discussion is widely spread, and several years ago, unicorns appeared, and now everybody, mayors, governors, presidents, want these companies be located at their territories. So new actors, not only corporations, but startups, unicorns, etc. And at least new spheres of innovation. And we believe from our point is that there are two paths of creating something new. First is science-based, and second is based on individual skills, and we call it creative path. So creative industries are also could be seen as a broad picture of innovation. And if we see at any innovative product, we could, it means for customers, at B2C market, we could see scientific innovation, so invention there, but also new design. So design is also important. So it means that new geography of innovation, it means simultaneously many things added as new. Uh, so, and we could also reflect and think about it. So our session, uh, what is the idea with? Many of you knows that we conduct uh, monitoring and evaluation of global cities, and our last report involves 200 of them. We are very conscious, interested scientifically about inventing the factors why some cities are prosperous and success in terms of innovation. And the first speaker is Kirill. He conducts his own research based on our database, uh, PhD research, I should also say it, and reflect about uh, configurations of cities. So how we could group the patterns of global cities, and what does it mean for policymakers. Then I will ask uh, Professor Lin Chen a director of Center for Industrial Development and Environmental Governance of Tsinghua University, and she's also very conduct very sophisticated research for many years, and also collect her own database of global cities, and of course had with her team own conclusions and tips for mayors. And it will be very interesting to see different point of view, what was done for us and what was done by Professor Lin. And after that, we go to Kristina with the completely different picture of maybe not small, but medium-sized cities, because Kirill and Professor Lin, we know very well her research, first of all concentrated, of course, it's obvious on large cities, but the question is open. Is it any space, any chance for small or maybe medium cities be attractive for innovators? And I should say that yes, but what are the peculiarities of these medium-sized cities? And this will be the goal of the Kristina's study, and she showed some results. And of course, I want to ask our audience, don't hesitate, ask questions, write your questions and comments, and as a moderator, I read everything and help authors to address it and to answer. Okay, let's start. And Kirill, a researcher of our team, Russian Cluster Observatory, a specialist in cities and unicorns. So the floor is yours, Kirill.
Yeah, unicorns will be in the next section. Right now it will be a little broader look. Okay. Good afternoon, everyone. Dear conference participants, my name is Kirill Tyurchev. I am an expert at the Russian Cluster Observatory of the Institute for Statistical Studies and Economics of Knowledge. And today I am very grateful for the opportunity to present my part of my PhD dissertation devoted to innovative cities. And the title of my presentation is "What do innovative cities looks like? Configurations of urban innovative systems." In truth, this report is part of my dissertation work, as was said, and which is largely inspired by our HEC GCII ranking, HEC Global Cities Innovation Index, the second edition of which we presented in April of this year. Thanks to him, we were able to fully explore the global innovative landscape, examined a huge number of different indicators related to innovation, and work out an approach to assessing the level of innovative development of different territories. In many ways, my report today is a continuation of this work, an attempt to understand our results even more deeply. Since I have been involved in public administration issues for quite a long time, one of my interests is the opportunity to apply these results obtained to real management problems. And today I would like to share with you some of these results of my work that I'm doing. Okay, of course, the attention of many studies and management practitioners today is focused on innovation. They are the key to the growth and prosperity of any economy, and also serve the main goal, improving the quality of life of people. The unevenness of innovation in space and their tendency to concentrate in space have already been fairly revealed, so nothing new here. Moreover, some have even formulated so-called stylized facts in the field of geography of innovation. For example, one of these facts states that the territories are not equal due to the effects of urbanization, concentration, and diversity, and so on. However, all these results were mainly based on the study of either patterns or scientific publications, or just studying specific cases. Of course, this approach is very limited from the point of view of governance of specific territories, because it says quite little about specific conditions of different locations. Currently, in parallel, there are quite a few management approaches that define certain models of city management. However, despite their great popularity among practitioners, they do not offer a theoretical framework that would allow a comprehensive assessment and comparison on different urban innovation systems. Therefore, today I would like to discuss with you how can the existing difficulties and limitations of studying urban innovation systems. I will tell you about my approach to their assessment, about how reliable this approach is from the point of view of the real economy, of course. And finally, I will talk about one of the specific areas, identifying urban innovation systems of various configurations, and how these results could be applied to solve real management problems. Of course, it will be worth starting with the fact that I took as a basis the concept of innovation systems, an approach that was developed quite a long time ago by a group of authors such as Lundvall, Nelson, Freeman, and so on, who have close ties with the OECD organization. The literature has long described a model of an innovation system within which business, academia, and the government are the key actors or agents of innovations. Of course, at present we can already talk about a wide range of participants, for example, public organizations. Then we will already be in the paradigm of the so-called quadruple helix. However, at the current stage, I would not like to pay much attention to this story. This is also a fairly large number of studies showing how the level of development of the innovation system affects the rate of economic growth. It's probably now difficult to find a country on which such a study has not been carried out. That is why researchers note that the lack of a systematic approach to understanding the innovation process can lead to a deterioration in the quality of policies to manage it. Of course, when we talk about identifying different configurations of innovation systems, they can be globally divided into two types. Firstly, it is the identification of configurations based on the assessment of the level of the development of the innovation system. This approach is traditionally used in analytical products, such as Global Innovation Index or Regional Innovation Scoreboard, for example. For example, the most developed groups includes innovative systems that, in terms of the development, lag behind the leader by no more than 20% to the next group, and the next group from 20% to 40%, etc. Sometimes this divisions is supplemented by the overall level of wealth, and this approach is done in Global Innovation Index. Also, I would like to characterize the second approach rather as exploratory. Within its framework, the authors strive not only to evaluate and rank territories, dividing them into groups, but pay attention to the individual elements of each innovation system, and on the basis of this, offer their own additional classifications. However, significant empirical work is mainly available at the country and regional level. Urban research in this regard is much more limited, mainly due to the fact that many authors rely only on patents and publications, as I already said. That is why The concept of urban innovation systems has been developed in recent years, and the problem of identifying their configurations is quite often highlighted by the authors who studied them. This is due to the fact that for the real management, you need to know not only your own innovation system, but also others. You need to understand your competitors, your benchmarks. Understanding the strengths and weaknesses of an innovation system is also only possible when you are comparing yourself with others. There are many explanations why cities have become such centers of innovation. As a rule, this is associated with the presence of an agglomeration effect and knowledge flows. There is a fairly large number of authoritative studies on these issues. However, I think there is another that is very often missed. Through this effect, cities produce superstars. This is a phenomenon when companies or individuals who account for the majority of profits or market volumes in certain types of activities. And initially, this effect was research on the basis of creative industries, for example, musicians, artists, writers, and so on. However, in recent years, a significant body of works has appeared that had shown that the presence of a similar effect among innovators, such as technology companies, researchers, universities, and so on. Thus, I propose to consider the urban innovation systems precisely as a collection of these same leaders who account for the largest market share in their industry. Here is some research design. Firstly, a list of these leaders of urban innovation systems was compiled. Secondly, the research database was formed and collected. Then some descriptive analysis was done. Then I used ordinal logistic regression to identify the relationship of the presence of urban innovation systems leaders and the volume of GDP per capita. And finally, I used fuzzy set QCA analysis to identify different configurations of urban innovation systems. Okay, that's how database and sample of the study was formed. I use 4 types of leaders. First of all, it's large technology companies included in R&D scoreboard ranking. It's 2,500 companies with the highest R&D expenses of the world. And these companies accounts roughly 80% of all business expenses on research and development. Second element is unicorn companies, as we think, new measure of successful and best startup companies. The third one is the leading universities, which are included in different universities world rankings, such as Times Higher Education, Curriculum Simondis, and Shanghai ranking of universities. And the fourth one are public research organizations with the highest output in terms of high quality publications. You can see the number of objects and the data sources. So what was the work? All these organizations were split among the cities. So we identified 1,900 settlements. It's not only cities, you should understand. Then we used some agglomeration techniques, which we used in our HEC GCII ranking. I won't waste a lot of time explaining it. Primarily, it's functional urban areas approach used by OECD. It's some national approaches to identify agglomerations, which are used in Brazil, India, China, and so on. The next part of the database formation was using data on agglomerations GDP from Passport Euromonitor. It's the largest database on economics of world cities. Additionally, we added some information on patents from PatStat Global and population of these cities. As a final, and the final sample is 1,167 agglomerations in 102 countries, which account for the majority of the leaders of innovation systems. You can see these numbers on the slide. Okay, here is some descriptive statistics about how these leaders of innovation systems disturbed among the between the research sample. As you can see, the most often in urban innovation systems you can meet leading universities. More than half of such organizations you can find in research sample. But if you look at the unicorn companies, we can see that their concentration in leading cities are very high. So only less more than 10% of cities have such companies. And if we are talking about large technology companies and leading public research institutions, they are quite the same. Have quite the same distribution, approximately 20%. And I also want to say about the cities of the sample. This sample is quite different. For example, we have the largest city in terms of economy, New York, and the last one is city Battambang from Cambodia. And in terms of population, we have the largest agglomeration of Tokyo with approximately 36 million people population, and not the biggest American town, Woodbury, with approximately 36,000 population. Okay, here is some correlation metrics, but I will skip it right now. What can we say looking at the distribution of leaders among different urban innovation systems? We can see that there is a power law. This phenomenon is very typical for various socioeconomic processes and points to the so-called problem of leaders and long tail. For example, using this curve, one can just justify that the powers for the actual implementation of innovation policy can be lowered to the city level only in some cases, when the city is really able to compete with other cities. I also want to mention that previously this phenomenon was one of the stylized facts that I mentioned already today, but previously it was found using the patent data. Now we can say that innovation leaders distributed between cities according to this law as well. Okay, as for connection between the presence of leaders and wealth measured and as GDP per capita, we can definitely say that such a connection exists, and for any type of leaders. The only difference is that technology companies have a positive effect on a city's likelihood of being ranked in a higher wealth group, while universities and public research institutions reduce this likelihood. It seems that this result is somewhat counterintuitive, but perhaps this is not the case. While companies have profits as their main goal, this is not the case for universities and research organizations. On the contrary, they are significant consumers of public resources. The mechanism of their impact on the economy of the city is of a completely different nature than the direct economic one. At the same time, the model based on information about four types of leaders was able to correctly determine the level of wealth in 75% of the cities of the sample, which can be considered as a very high result. For example, when scientist Kogler looked at the relationship between patents and GDP per capita using the example of American cities. Using correlation analysis, he discovered a strength of this connection equal to 70%. And finally, let's talk about configurations. The slide presents all 16 possible configurations based on the presence of leaders in the innovation economy. And these configurations on this slide are ranked by the level of their median GDP per capita. And here is some conclusions from these configurations, but not the all, of course. First of all, most of urban innovation systems are characterized by the presence of a small number of leaders of the innovation economy. The most developed group, which has the highest average GDP per capita, has all 4 types of these leaders. And this group consists only of 35 cities. 5 of 16 groups can be called niche because they are quite rare. You can see that some configurations, I will change the slide, consist only 5 cities. For example, group number 4 and group number 5. Yes, they are quite small, so it's not a I want to say that they are quite rare. Okay. Also, what is important here is that first 11 configurations necessarily contain either large technology company or unicorn companies, or both factors at the same time. That's why they are ranked high among the groups. Apart from the group without leaders of urban innovation systems, the most common model is the one with the presence of leading universities. And you know that this group is quite well studied in researches. It's so-called student policies. So we really have a lot of researches on this group, but others group are still, I want to say, not so good researched. And I also want to mention that the first 4 groups always have a leading university. It's always very similar to the stylized facts, which says that all leaders of innovation development have leading universities. So the theory is approved. Okay, the last question is how can these configurations and the results be used for real city governance? First of all, the full list of cities were created, and some of the cities can be targets for policy, for innovation policy, or additional resources can be delivered to these cities for their more intense development in terms of innovation. The second part is that cities now can see in which direction they can develop, what configuration they can have if they want to be in more effective groups. For example, if we look at the group number 3, which includes Moscow, yes, the capital of the Russian Federation, we can say that if it wants to compete with cities from the first group, it needs to develop its knowledge-intensive entrepreneurship, first of all. Of course, these configurations allow to better understand the competitive environment of cities, but also it allows them to find partners abroad to compensate their weaknesses, the so-called joint projects, for example. And of course, from 4 different configurations, different management models can be used. For example, if we are talking about complex innovation urban systems, then we can use cluster approach, for example. And when we have a configuration with only presence of one type of innovation leaders, for example, large technology companies, we can use different policy instruments, such as creating consortia and so on. Okay, this is the last part of my presentation. Thank you very much for your attention. I am ready to answer your questions.
Okay, thank you very much, Kirill. Yes, if somebody have questions, you could ask. All right.
Okay,
I could start maybe. I could ask a question
okay.
to you, Kirill. Uh, yes. Quite quick question,
Uh-huh.
technical. You are talking about the impact, the influence of universities on welfare,
Yes,
yes,
yes.
GDP per capita. Do you use some leg specifications? It means that first you need to establish a university. It should be prosperous and it takes decades or maybe hundreds of years, who
Yeah.
knows, yes? And then uh, the city flourish. What do you think? Do you use this leg? Because if you just opened a university and you are waiting when you became
Yeah.
rich, it looks quite naive.
Okay, thank you very much for your question. It's a very good question. I don't use any luck models, and I think that this is a limitation of my research. I think that in the future, these options of how to move, how to uh, do less limitations is a good way. And I think that we can use two ways. For example, this is the way that you mentioned. Yes, considering the year of the establishment of the university. Another possible way is considering its type. Is it public university or private university, of course? The third possible way is the quality of this university. Yes, if we are taking these rankings, we know that some universities are top universities, yes, and the low rankings, the universities are almost unknown only uh, for a wide range of people. So yes, I think this model can be developed in several ways, and it's a great idea. Thank you.
Uh, yes, I'm not sure that it's so great. Of course, it's uh, quite easy. I think that, of course, I'm hearing uh, your results and I'm looking at them several times and I'm also thinking how to develop it. And frankly speaking, I think that this QC analysis has a lot of limitations and you should think about
Clustering,
cluster
yes,
analysis.
yes,
Yes, it's more traditional, but you will find out sustainable
configuration, yes.
patterns of cities. Yes. I think that everybody wants to know how actually global cities with these innovation actors, innovation leaders, dispersed across the world, and what are their partners. Yeah, so let's think together about it. And I just want to add, don't want to ask you any other questions. I'll do it personally, so we'll think together. But I'm just looking that there are more than 50 participants, yes, hearing
Yeah.
us just now. And I just want to invite somebody who is interested to join and to think together. So we are we are go at this path for several years and also thinking about what could be the next step. Okay, thank you very
Thank
much,
you.
Kirill. Good luck with your future PhD, yes. And I want to give a floor to Professor Chen, director of the Center for Industrial Development and Environmental Governance of Tsinghua University, and the author and facilitator of the research team, who also published a very interesting Global City Innovation Report. Professor Chen,
Okay.
I see your slides.
Yeah. Thank you, Chairperson
Floor is
Evgeny,
yours.
and thank you for your kind words to introduce me. And I also would like to thank Kirill for inviting me here. It's really it's a great honor, and I also very delighted to be here to discuss with you. And I just heard your presentation, and I actually find lots of lots of our common bases that we can discuss further and maybe cooperate further. So yeah, good day, and everyone, our distinguished panelists and dear audience. And I'm Lin Chen from Tsinghua University, and I'm very excited to share with you our researches on the Global Innovation Hubs Index, we call XIII Index. So I will focus on the evaluation method and its applications. My presentation will, have 4 parts. So we will go through a research background, then the method, and briefly introduce the results, then some applications. First, yes, we all know that the innovation network worldwide is currently being reshaped dramatically by those new waves of scientific and technology revolutions, as well as the significant shifts in international political and economical dynamics. Actually, on the APEC arena here in San Francisco, and we found lots of like U.S.-China, tech war and trade war argument here. So I feel like it's real. The geography patterns are changing, and so to assess, depict, and track those dynamic evolution of global innovation hubs, my center, and also together with Nature Portfolio, has developed the Global Innovation Hubs Index. It was first released in 2020 during the COVID-19 pandemic, and the 4th one will be released very soon in the end of this year. And in general, our research has 3 following key goals. So first, we try to define the essence or specific manifestations of the global innovation hubs, and we'd like to construct a conceptual model for innovation assessment. And the second, we'd like to address those actually a bunch of technical challenges for innovation evaluation, such as I think Kirill must be very familiar with that there's various sides of administrative cities in different countries, and even different definitions for the same statistic indicators. And also we are facing severe data gaps at the city level globally, and so on. So finally, we'd like to comprehensively apply our spatial econometrics and artificial AI algorithms and multi-source data integration and the network analysis method. We would like to combine them together to establish a scientific, transparent, and credible evaluation system. We try to, combine all those complex into one index. So it's kind of a challenge. And here's our conceptual model. So the GHI assesses global innovation hubs in 3 dimensions, which we call innovation, research innovation, and innovation economy, and the innovation ecosystem. So those 3 dimensions are mutually interacted. So the first dimension is like here. Can I see this? So here is the scientific research. So we include like human resource infrastructure and research institutions, and finally knowledge creation, to combine those 4 factors together. And for those innovation economy, we measure their GDP and their business and industries in advantage area, and we also try to measure their technology capacity by patent application. So finally, the ecosystem, we try to measure those like museum, library, and the culture, and also the cooperations between cross borders. So they actually mutually interacted. So so now it is our attention to those main features. I would like to see the main features of our index, GIHI index. So there are 3 main features regarding our method. So first, we have constructed a comprehensive innovation measurement model at the city level and worldwide. Compared to the existing ones, GHI features itself by 3 aspects. So I think, so first we define the scope of a city sample, and then in the area of urban delineations, and then we use some models. So here is kind of the way we define a sample. So we understand that globally, the skills of the city is varied. Some cities only like have like maybe several thousands of population, and like in Beijing we have like 20 million populations. So it's very hard to just compare them together. For example, we see San Diego. San Diego is actually less than 1 million population, and also San Jose. But when we talk about San Francisco metropolitan area, it's have like let me see, 7.5 million populations. So which San Francisco would like to compare with? We need to have a comparable scope for those city assumptions. So we introduced a novel approaches by employing a density-based noise-affected spatial clustering algorithm. And we use like intercity innovation collaboration intensity for urban clustering. Namely, we use the data that people who co-author with each other. Then in that way, we found that they have relationship in the research activities, innovation activities. Then we circle them together. So in comparison, our metropolitan region clustering results demonstrate a remarkable fitting of over like 96% when compared to those definitions of related urban statistical regions in the United States and Europe. And here is the as I introduced earlier, so we have sort of a very comprehensive measure model. We have like 3 level indicators. So in the first level we have 3 dimensions. In the second level we have like 12 indicators. Then in the third level, which is the most detailed level, we have like 31 indicators. So that makes it possible to compare in the city level. So we have sort of a benchmark. Our primary benchmark is the GII, Global Innovation Index, which published by the WIPO, but it's like in the country levels. But our GIHI is in the city levels, and I also noticed that Kirill's data is also in the city level, which is very, very, very. It's not easy. I understand. And here's the way we measure the international innovation hubs. So normally, people measure innovation hubs use their input and output model, but I think it's too simple, and to symbolize the innovation activities. To understand the essence of the innovation activities, we try to combine the city-specific indicators with the urban network indicators, and we combine the general innovation factors like human resource or some other resource, and with those high-end innovation factor indicators like science infrastructure or sort of things. And also, how to move on this arrow. Oh, here. And by those way, we try to capture the true essence of innovation activities. So we have indicators for like international flights, museums, unicorn companies like Kirill, and many and FDI or FDI sort of things. Next. Yeah. Then we also conduct evaluations for those index. I call it evaluations of evaluation. So we conduct consistent analysis between the first level indicator with second level and the third level indicators. So make sure those indicators are consistent in different level. And also we conduct sensitivity analysis. And the right figure shows that we use the 2021st data. It will show that highly ranked cities are quite robust. We run the Monte Carlo method to see if we change the data, what's the ranking of city could be changed. So it shows the highly ranked city like Beijing, San Francisco, London, New York are kind of consistent. I mean, kind of robust on the high level. So then I see. Yeah, then the second feature I would say we combine all those different database together. In the left side, we actually it shows that we use like over 100 commercial and open source technology or database, data mining technology to combine those together. And I just take one as one sample. Like we use the mining of like 17 billion citation relationships data. Then we introduce the indicate that it's a ratio of scientific paper cited by patent, clinic trials, and policy documents. This indicator reveals those impact of basic research outcomes in their impact in the industries, medical and policy domains, as well as the level of knowledge transfer. We optimized those innovation indicators, such as the number of active scientific scientists, and also some identify those the highly distinguished scientists. Oh, oops! I forgot to shift. Yeah, here's the way we combine those database together. And next slides. Next slide shows our method to use or clean the pattern database. We rely on those different pattern database, but we have established for the first time a reliable city level pattern assessments database for three we saw cutting edge frontiers technology, which are AI and IC and renewable energy. And so we hope it could give us better understanding of those innovation hubs in those areas. Compare with, we combine all those patterns together. And the data cleaning strategy are also very complicated, but we now have sort of confidence that our data cleaning methods are more reliable than traditional ones. We actually use that algorithms to clean the patterns from like 17% to 16 to 86 to 96%. The third feature I would say of GIHI involves measuring the positions and the dynamic evolution for those central cities in those innovation network, hopefully providing insight for policymaker. And here's the example. And based on those extensive relationships data derived from pattern co-application or research paper co-authorships, we're applying community detection algorithms and also network metrics to construct global innovation networks. And we can access those significance of the cities within those networks and measure the extent of their influential diffusions. Here are also an example. So we can tracking the dynamic flows of global innovation factors throughout, like in the whole process, such as the mobility of high-end talents and also international flights, density, foreign direct investment, venture capital, and so on. By doing so, we can review the evolution of cities' position in the global innovation ecosystem. So in the right side is kind of the geography distribution of our samples. So finally, the results. So we combine all those database via very complicated methods, but we try to keep it very, very simple and clear. So here's a sample of our ranking. So it turns out that the San Francisco always standing the #1 position, in the New York, Beijing, Hong Kong, Shenzhen, Guangzhou, Bay Area, and Tokyo, London, all those cities are quite robust on the top ranked position. But there are some dynamics, like Shanghai actually rising very quickly, and also Seoul, Geneva, and the Kyoto sort of cities. In this year, we will release this year's reports very shortly, but we can see there are some dynamics, but also there are some consistency with the older one. Yeah, from the perspectives of those geography and also the results, among the 50 cities or metropolitan areas, the United States and Europe each accounted for like 17 seats, and Asia, which is amazing, accounts for like 11 seats. And but in the top 20 cities, Asia and the United States each account for 7 seats. So we can get a conclusion that Asia has become one of the most dynamic regions for global innovation and development. Shanghai, and I also said before, Seoul, Kyoto is kind of samples that rise very quickly. And we also conclude that the Bay Area is the most active areas. That we have 4 Bay Areas: Tokyo, New York, San Francisco, and also Shenzhen, Hong Kong, Macau Bay Area. Those 4 Bay Areas are ranked top 10. So it's I think it's like a geography benefit from those locations. Okay. Finally, the overall scientific and technological innovation capacities of Chinese cities are actually changed very quickly and improving actually, but the ranking distribution is relatively scattered. So just 3 of them are quite high ranking, but the rest of them are pretty low ranked, but it's changed quickly. So finally, I'd like to see just one slides on our influence. So we actually published this report, index report, on Nature websites, and for 3 years, and then this year also. And last year, we used those methodology to conduct a new index, which is the Asia Pacific Industrial Sustainability Index. This index was published in science websites and also the magazine. And this is why I was here in San Francisco, because I work on APAC Chinese Business Council to measure Asia Pacific cities in terms of their industrial sustainability. And also third, this GHI index provide sort of support to our Ministry of Science and Technology and also Beijing Manchu government. I think I'd stop here. I hope I didn't run out our time. So it's time for questions and comments. Thank you.
Thank you. Kristina, now I want to go to your presentation and to the, I've just announced, yes, I was right. When at my introductory words, I said that Kirill and Lin will say about huge cities and even agglomerations, yes? You saw it by your own eyes. But are there any chance for not huge cities, not capitals? What, because yes, we calculate, so we divide a number of innovative leaders to the population, and we found out that there are medium-sized innovative centers that are extremely efficient. But what are their success secrets? Kristina, please give a light on that.
Thank you very much. Good afternoon, dear colleagues. My name is Kristina Boyakova, and I'm an expert at Russian Cluster Observatory Center of Institute for Statistical Studies and Economics of Knowledge. Today I will present the preliminary results of this study, the success secrets of the medium-sized innovative centers. I plan to go over the core findings that have been derived so far by our research group. So let's dive into the key findings next. First of all, I'd like you to pay attention to the literature, relevant literature articles that are devoted to the innovation and location. Many scholars argue that large cities are innovation machines and that agglomeration economies are a requirement for innovative activity. In the literature on geography of innovation, there is urban bias, distinct urban bias towards the large agglomerations, large cities, the economic cores of the world. However, there is a large group of cities outside the focus of researchers. They are called as small and medium-sized towns. The next point is that innovation is not necessarily related only to geographical factors, because the emergence of high interaction environment can help small cities and medium-sized cities to overcome their geographical factors. So such environment arises as a result of combination of local factors and access to external factors, including interaction with external actors. Turning on to the conceptual scheme that was developed, conceptual scheme of medium-sized urban area with the highest concentration of S&T leaders that you can see below. Science and innovation leaders, which are leading companies by R&D expenditure, unicorn companies, leading universities, and highly cited researchers that are being affected by the factors of urban environment, such as openness and quality of life, transport accessibility, quality of human capital, knowledge and technology, and urban environment, which will be explained further by me in the next parts of my presentation. So this all constitutes a medium-sized urban area. First, I think that it's important to outline that the research is primarily based on the HSE GCIA 2023 data. As you can see that on this table, that among top 15 cities with the highest concentration of innovation economy leaders, which includes not only enterprises but also individuals. They are located mainly in the OECD countries, which is a substantial part of such medium-sized innovative centers. And in the top 10, we can see that there are only two large agglomerations, such as Boston and Munich, whereas other they cannot be labeled so. And so we raise two big questions. So first is how medium-sized cities attract science and innovation, science and technology leaders, which I will call S&T leaders, and what are the common features of medium-sized cities with the highest concentration of S&T leaders. So our research focus is on the OECD member countries. However, it's important to outline that there is an international comparability problem because urban development is still poorly monitored, and statistically robust comparisons of urban areas across countries are challenging for experts and scholars. So as you can see, according to the Global Innovation Index 2023 rankings, there are among the top 20 of the Global Innovation Index economies, there are 17 OECD member countries. According to the top 50 highly productive innovation clusters, which is the separate section of the GIA 2023, 42 of them belong to the OECD member countries in terms of the productiveness of innovative clusters. It's important to outline that there are diversity of definitions of what is an urban area. There are multiplicity of official concepts on how to delineate the extent of conditions of city, and an array of measurement techniques. Our research focus is on OECD countries. There is a specific concept of functional urban area, or FUA. And the algorithm derived from the redefining urban OECD reports. It can be said that the functional urban area is a solution to the international comparability problem. And functional urban area is an economic unit characterized by densely populated urban core and hinterland based on the connectivity of labor force. And it can be seen that geospatial data is used in order to outline, to demarcate the borders of urban areas. So on this slide, you can see that medium-sized urban areas are the most numerous category of FUAs with S&T leaders. How we reach this conclusion? So first, each S&T leaders worldwide was assigned with locality. So all of the localities are 1,557 localities in 110 countries. So you can see that because we focused on OECD country members, we use the agglomeration method in order to assign each locality with a functional urban area. And it was revealed that, interestingly, 89.3% of S&T leaders are located within the borders of functional urban areas. And this is actually the largest, the most numerous category of FUAs, which consists of 200,000 people to 500,000 people. It's population threshold based on the OECD 2012 report, and the number of such FUAs is 204 FUAs. Next, we developed. We approached the box plot visualization method, and it was found out that the highest number of extreme values of S&T leaders concentration is a distinguishing feature of medium-sized urban areas. As you can see on the left side of the slide, there is a formula of leaders concentration, and the number of extreme values are varied depending on the type of functional urban area. So medium-sized functional area consists of 23 observations or urban areas with the extreme values of the concentration. So speaking about database briefly, it needs to be stated that only 4 types of innovation economy leaders were selected, mainly S&T leaders, which are, in particular, there are leading companies by R&D expenditure, unicorns, leading universities, highly cited researchers, and this is based on the study on the study that consists of the data collected during the XIII Global Cities Innovation Index was made. So there are 23 medium-sized urban areas with the highest concentration of S&T leaders. And also we have developed conceptual dimensions of an urban innovation environment, and you can see that to each conceptual dimension there were specific variables assigned to each conceptual dimension, and you can see the sources of the data and the periods of the data. It is an urban innovation environment that I previously described when I was explaining our conceptual scheme of a global medium-sized urban center with the highest concentration of S&T leaders. Next, I'm going to briefly explain the main results that we obtained during this study devoted to medium-sized urban areas or innovative centers. It is in each case, in each observation, medium-sized urban areas were there were data collected in each case in each medium-sized center. So it was revealed that medium-sized innovative centers are located in the wealthiest economies, but they are not distinguished by higher salaries, as you can see on this slide. So first of all, such conceptual dimension as quality of life. The GDP per capita data was collected. The median value for the GDP per capita at the full level is actually high. It's 54,194 United States dollars, whereas the median value of OECD countries with S&T leaders is $58,000, which can be concluded that they are located in the wealthiest economies of the world. However, it is interesting to investigate the average monthly net salary after tax. So the average monthly net salary in medium-sized urban areas are commensurate with country average, as you can see, this visualization depicts us. Thus, a high salary is not a prerequisite for S&T leaders concentration, as you can, as the data depicts. Turning on to the next dimension, we also collected data on the time to the nearest international airports by car in minutes and time to the nearest large city with a population of at least 5,000 people, which all of that constitutes transport accessibility, and the median value was calculated. So the median value for the time to the nearest large city is 80 minutes. Which demonstrate a high transport accessibility of these medium-sized urban areas. And the share of foreign students consequently were collected in the city level and at the country level. So medium-sized urban centers with the highest concentration of S&T leaders are attractive for international students, and 16 out of 22 cities have higher share of foreign students than its national average. So the median value of the share of foreign students for countries 14.3%, and for the city level, this value equals 20%, which is higher than its national average, as I said previously. Also, the other key findings that we derived is that leading university is a must for innovative center. As you can see, the distribution of cities where leading universities are located, these universities are internationally recognized universities by international rankings of higher education institutions. So the universities included in the top 300 universities of the world are located in 15 medium-sized functional urban areas of our study sample, and the only medium-sized city that doesn't have any leading university is Benton. However, in Benton there is the Pacific Northwest National Laboratory that is located in there, which is one of 12 national laboratories under the Ministry of Energy of the United States. And the second graphic depicts that medium-sized urban areas with the highest concentration of S&T leaders might be considered as students for life due to the high proportion of students in the city population, which proves the data on the share of students in the total population of functional urban areas and in the country level. The next key finding is that medium-sized innovative centers are not necessarily located in innovative regions. So each medium-sized urban area was assigned with Tier 3 regions, not 3 level, And on CD stat, we collected the number of patents and filed under the Patent Cooperation Treaty, and the name of these regions you can see as observations. It was revealed that 16 out of 23 medium-sized urban centers with the highest concentration of S&T leaders are located in regions whose share in total patents does not exceed 5% level. It is remarkably that they are located, not of them are located in highly innovative regions within its countries. Turning on to the next element of urban innovative environment, which is internet speed. On speed test website, we collected the data on the internet speed in each city, and also we collected the data on country average. So 18 out of 23 cities have higher internet speed than its national values. Also, it is interesting that the median internet speed of the United States medium-sized urban areas exceeds European internet speed by 1.86, almost 2 times, as it was calculated. It is important to highlight that this dimension of urban environment within the urban innovation environment is interesting in results. And in conclusion, I would like to briefly outline and highlight some major common features of a global medium-sized innovative city. First point is that medium-sized urban areas with the highest concentration of S&T leaders in the world, they are located in the global wealthiest economies. However, if we look at the average salaries data, it is evident that they are not substantially exceed their national values. Medium-sized innovation centers are not necessarily located in highly innovative regions. For example, Gainesville, Tübingen, Uppsala, Groningen, Surrey, these regions are not. It cannot be said that they are highly innovative due to the share in total patents. The next key point here is that a majority of the global medium-sized innovative centers have high internet speed compared to its national speed level. So this is an important evidence on the infrastructure of the city. And 22 out of 23 cities have at least one internationally recognized university. 19 medium-sized cities have universities included in the top 300 universities of the international rankings. And remarkably, students' share in total population is significantly high, including the proportion of foreign students that came from all over the world to this medium-sized urban area. And last but not least is the key finding related to the openness. It is surely a key feature of a global medium-sized city. S&T leaders thus reside in urban areas near large agglomerations, large cities, which are also attractive for foreign students. I'd like to thank you for your time and attention. If anyone has any questions, I'd be happy to open up the discussion. Thank you very much.
Yes, thank you very much, Kristina. What about discussions? One. So we have the opportunity to ask a question. Here. 2. Okay, 3. Yes. That's quite interesting because it's just our ongoing research, and I have a lot of questions to myself, of course, uh, about these cities. Yeah, just maybe I don't ask the question to Kristina now. I just want to comment from my side. Just returning to the ratings. Yes, if we look, for example, at GII, we see that China and US are very close in the number of top innovative cities, and the same with our ratings. But what we found out, it's quite interesting. If we look at top 10, top 20, maybe even top 50, yes, we see a parity between US and China. But when we look at top 100 or top 200, we see that US has a lot more cities. What does it mean? It means that in terms of the top cities, large cities, agglomerations, these are now close to be equal. But United States has a strong belt of second and third tier cities. And it means that we need also them. We need also to think about it. And at Soviet Union, we built so-called science cities. And now we have once a discussion what to do with them, how to reinforce them, how to revitalize them. And that is why we go to this agenda. And we found out that, just one example, these cities are built not around science organizations as it was in Soviet Union, but around universities. They could be called studentopolis, so a lot of students, a lot of international students. They are open, good located, they are digitalized. So brilliant digital infrastructure, and these cities attract not only students, then startups, unicorns, corporations, and it means that Kirill said, and I asked him how university uh, uh, could uh, could impact on welfare. That is the way. So through attracting business, innovative business, but yes, it takes time and it takes a lot of conditions, which is described by Kristina. So and one more comment. It just could be also concluding comments and my recommendations from my side to Myers, because yes, there are some fundamental factors that you could not do anything with them. Uh, it's very difficult if you are not living at the sea, just so you could do nothing with that. Yes, you could build a channel, of course. Yeah, or if you are not a capital, so it's very difficult to become a capital. Yes, uh, or to attract millions of new citizens. But this research of Kristina showed us that these medium-sized innovative cities, many of them are located not at the richest regions, and these cities are not the richest, not at the top of the welfare, and some of them located even not in the most innovative regions. Because if we talking about United States, yes, it's very easy. Silicon Valley or California, better to say, New York and Boston. That's 3 points. They account the majority of all innovation. But here we see, just for example, Boulder, yes, in the United States. Uh, it means that you could be not the richest, located not in the most innovative region, but if you invest in university, attract students worldwide, invest in digital infrastructure, you have airport or build it or uh, 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 do it better, you have a chance. And it means that this success also in your own hand. And I think that's the good concluding remark for today and recommendations for mayors and for urban societies. Believe in yourself and build year by year, generation by generation, your own success and find your own path to be innovative, because innovation, it means prosperity at the end in this current situation. So thank you very much. Thank you, my colleagues. Thank you, Professor Lin Chen. It was a pleasure to discuss these issues with you, and I hope we'll see later. Thank you very much.
Okay, thank you. Thank you all. Sure.
Thank you very much for
Thank
the
you.
interesting discussion. Bye.
Goodbye, dear colleagues.
Bye. Bye-bye. Have a good day.
The same.